Hello everybody. In this video, we are going to see what's a strong number and how to find a strong number using Python programming language. Strong numbers can be termed with these names also: Krishnamurthy number, special number, or Peterson number. What's a strong number? A number is said to be strong if the sum of the factorial of the digits of the number is equal to the number itself. So for example, if you take 145, its digits are 1, 4 and 5. So you find the factorial of each digit. That is 1 factorial is 1, 4 factorial is 24 and 5 factorial is 120. So if you do that, 1 plus 24 plus 120 will give you 145. So in this case we say 145 is a strong number. So it's basically a very simple procedure to do. So just we have to extract the digits, and then we have to find the factorial of the digits individually, and then we have to sum the factorials of the digits. Then we have to compare the sum with the original number that we have. If both are equal, then we say that number is a strong number. Let's see how to implement this in Python. So first we'll get input from the user. The user enters a number. We just have to find whether it is strong or not. So in case of n, I'm getting this input. The user enters the input, the number. So we'll write one function is strong. So it will get that number. We'll check. So the number that user enters is passed on to this function is strong. So the is strong is a function which will return true or false. In case of a strong number, it will return true. If it is not a strong number, it will return false. Okay. So based on that, we're going to print it. So if is strong, if I pass that one, if it gives it true, then we are going to print number n is strong. Else we are going to print n is not a strong number. N is a string here. I did not convert to number. It's a string here in this place. So we are passing the string here. So the advantage of having the string is we can use a for loop to just go through the digits. So if I perform a digit-wise traversal for I in n, so one by one it will take. Say for example, if I entered number 7408, so that is n. Okay, so n is equal to 7408, but it's in string format. So in this case, it will go through this n. I is pointing to character by character. I will point. So we just have to find the factorial of each digit. So now when I point to 7, we have to find the factorial of 7. So then we have to accumulate the summation. So we are going to declare sum equal to, or I just put s equal to 0, one variable, local variable to this function, local to this function. S equal to s plus, we'll find the fact of I. What is the fact of I? So we will write one more function, fact. It will get a digit and it will give the factorial of that digit. So if I digit, I just say d, okay, d for digit. So we are passing this I is pointing to 7 initially, it is going there. S is initially 0, so I goes here. So I is 7. If 7 factorial, it should return. It will return a number, the value, factorial value. So now when I pass here, there is a character actually. I is a character. So we have to convert to a number before working with the numbers. So now here we'll change it to a number. Say value, we just say value equal to I'll just say t equal to num of d. Now here not a num, sorry, int of d, just converting that to integer. Now for j we can use j in range, we can use 1 to d plus 1 now. So we are going to find the factorial here. So here f equal to f star j. So f is a local variable, it is declared to 1, initialized with the value 1. So now it's simple factorial finding loop. So we are starting from 1, and if we are passing 7 is d, so 7 plus 1 8. So the loop, the range goes from 1 to 7. So we are multiplying from 1 cross 2 cross 3 up to 7. So that is why this plus 1 is added. Once it is done, it will return factorial. So this factorial will, that value will come here, it will be summed up with the sum will be having finally. So once the entire loop is over, so first 7 is passed, 7s will be coming here, sum is updated, then 4 is passed, 4s will be coming, and then 4s is updated, then 0. We have to take care of 0. If we pass 0, 0 factorial is 1. Okay. So in this case, if we just put if d is equal to 0, 0 factorial is 1. So in case we return 1. So otherwise it's all fine. So 0 factorial is 1. So we'll return 1. It can be taken care of here too, because if you pass 0 here, this loop will not run because it is 1 and 0 plus 1. 0 plus 1 is 1. 1 to 1, this loop will not run, so obviously it will return 1. So just for the understanding, I am saying 0 factorial is 1. So we can remove this one, there is no need for this because it is taken care. Even 0 is passed, 0 plus 1 1, range 1 to 1, it will be blank, so it will not enter the body. It will return if f is initially is 1. So that will be returned for 0 factorial. So 0 factorial, and then the 8 is passed, everything is the summation, final sum will be here. Once the final sum is here, I am in this indent of for loop. See the indent, for loop's indent. So here we are coming out of the body of the for loop. If yes is equal to this string, actually this is a string. So here I am passing the character only, here only we are just converting to integer. So when s is getting compared with this one, so we can just say int of n. If both are equal, then we are going to return true, else we will return false. So this way it will go here. So first we are getting the input, it's in string format. That string is passed to a strong function. A strong function will return true if the number is strong, false if the number is not strong. So here we are initiating sum equal to 0, then we are passing fact of I. So I is a loop which is going through the number we are giving. So example 7408. So one by one it goes. So it wants to find the 7 factorial. It goes here. It's still a character. First character is converted to integer. Then f is a accumulator of the factorial value, that is initialized to 1. Then it ranges from 1 to d plus 1, because if I want to do 7 factorial, I have to give the range, right side range as 8. That means it will go just before that one. So 1 to 7 it will go. So we are multiplying the j with this f in accumulated way. Then we are returning f to this point, to this place. So I hope this will work fine. Let's try, because 145 is a strong number. It is showing 145 is strong number. Can give some space to this. So if we give anything else like 3 to 3, it's not a strong number. 1 is a strong number. 2 is a strong number. 2 is a strong number. Then we have a number which is in the range of 40,000. That's also a strong number. So basically this is a program to find whether a number is strong or not. Now we are going to just customize this program to find the strong numbers in a range of numbers. Say for example, I'm giving from 1 to 10 lakh, print all the strong numbers present. So if you want to do that, you just have to tweak this code to work for the range. Let us see how to do that. So we will just replace this input getting with a range. So for example, for I in range, we are going to find from say 1 to 1 lakh and 1. That means till 1 lakh, from 1 to 1 lakh, if you want to find this, whether they are prime or whether they are strong or not. So the range is given. So from 1 to 1 lakh, what are all the strong numbers present? So in this case, it's a number. This is not a string, because the range is a number. It's an integer. It's not a string. So we have to just pass is strong. That is fine. Is strong. It will be passing. We are passing this I. So if it is true, we just print the number. You just print the number I. It is strong. Else we will not do anything. We will just print strong numbers in this range. But what you have to remember here is there is a number range. It's not a string. But so here I am passing a number, integer. Passing integer here. So it will not work, because I in this is not a collection. So first of all, we have to convert n equal to str of n. So in this place, now we have just converted to or we just say n underscore s in a string format. N is a number format, so here n underscore s string format is going. Here there is no need, because n itself is a integer. N is an integer, so we are just checking whether the sum is equal. If it is equal, we are just passing true, otherwise we are passing false. So first we are converting to integer string, then string is a collection, I is passing through the string. That's the only thing we have made a thing. Okay, so I hope this will do the job. So let us just go through this. So code starts here. Others are functions. There's a fact function, a strong function, and we have a range code. For starts here, range 1. So 1 is passed, is strong 1. 1 is going here. We are converting 1 to string. We are converting 1 to string. S is initially 0. Fact of 1. Fact of 1 will be returned 1. So in that case, 1 is equal to 1. So return true. Okay, so likewise it goes. Let us see how it goes. We have 1, 2, 145, 40585. Still the program is running, because we have given up to 1 lakh. These are all the strong numbers up to now. 1, 2, 145, 40585. But still the program is still calculating. We can refine this code to a certain extent. How to refine this code? Let us see. While it is calculating, see what we are doing here. We are passing the digits to this one again and again. See, if you have found a 7 factorial, it's always 7 factorial same. That is, nothing is going to change. So if the number is 7 factorial, why we have to find again and again? So we can find factorials of 0 to 9 and we can store it. That can be reused for digits. Here in this case we are passing it's again and again. We are calculating the factorial values, so that is why it is taking a lot of time. So what we can do, the refinement process, we will first calculate, generate, okay, we will just generate fact values. There is a function we will write. This function will first generate the factorial values. Say for example, fact values. Initially we will have a list. A list is empty list. Fact values. Factorial values, you can just say. So here we are gonna generate the factorial values of 0 to 9 and then we will store it here. So for I in range, we will go from 0 to 9 and we will store it over there. So instead of this one, the generate function, instead of this one where we are finding this, we can use it to generate. So for I in range 0 to 10. So what we can do, we will call this, what is this function? The fact finding. Only one time we'll be using this fact finding thing. So fact, what we are doing, we will just pass I, where it is because it's a number, we are passing the number only. This is a number. No, we are characters here. So I will just remove this one. It's a number we are passing. So it will return the factorial value of the digit. So we are starting from 0 and it goes all the way up to 9. So that factorial is there. So this will be stored in the list fact values dot append. So we are storing 0 to 9 indices will have the factorial values of 0 to 9. So 0th index will have 1. First index will have 1. Index 2 is a factorial value of 2. It is 1 into 2. Index 3 is a factorial value of 3. 1 into 2 into 3. Okay. So likewise we will have 0 to 9 factorial values are stored in this list. So this list is ready now. So we don't need to call this fact again and again from a strong function. So a strong function will not utilize this function because it's already calculated. This is calculated. Fact values is having all these. Okay. So we are going to utilize this fact values. So how are we going to do that? So we got a number and it's passing through, okay, a string. It's passing the digits, okay, one by one. So corresponding digits thing we have to get it from that array. So we just convert to integer of I. So that one will be taken. So if you're looking for a digit 5, you need a 5 factorial. 5 factorial will be present in index 5. So index 5, I have to just convert that into an integer. Then I have to just get it from that array, that list, fact values list that we have generated. So initially, before coming to this one, we call this gen fact values. So it will generate all the things. So it will come here. Then when we call this strong here, it is going here. Then it will never call fact finding. It will just use this stored values. So in this case, we just find the factorial of 0 to 9 only one time, and we are storing it and we are reusing it. So apart from that, everything is same. So let us see how this works. I hope see, program ended so quickly. The same thing only. What we have done, we just reuse the value stored. Same thing. I didn't change this. 1 to 145, 40,585. So this is the um, strong numbers in the range from 1 to 1 lakh. So if you go from 1 to 10 lakh, one more zero added. Let's see how long it takes. 1 to 145, still blinking. It's done. So there is nothing after this 40k. So if you increase it, you have to refine in another way. So we have this. So this is a program to find strong numbers in a range. So if I take you through again, so first, these are all functions. First we are generating. This function is called. This function generates the factorial values from 0 to 9 and store it in the fact values lists. So it will be used while finding the strong number. So after this, it's coming here, the range is given. Strong we are just calling. So a strong function will just accumulate things digit wise. So it will just get the digit, and the corresponding digits factorial value will from the fact values list, and it is accumulated one by one. Then finally, once it is done, we can check it whether it is equal. If it is equal, it returns true, otherwise it returns false. Some more refinement can also be done here to speed up the work. Say for example, while we are doing this sum, if sometimes sum will exceed quickly, if yes is greater than n, then there is no need to go further. It's not going to be negative, it's not going to reduce this. Once it is exceeding, okay, once if it exceeds, then we can just return false here itself. So one small checking we can put. So in the case of a lot of numbers, bigger range, this might save some time. So when you are going on accumulating, if at a certain place, if the sum is exceeding, say for example I have 10 digits, fifth digit itself, while accumulating at fifth digit itself, it is exceeding the number's value. The sum is exceeding the n. That means I just have to return, because what's the point in accumulating 6th, 7th digits and all? 5th digit itself is exceeding. So we can add this one as a refinement. We have to run time functions to find this. So this also one case. We can implement this one. I hope you have found this useful. Thank you for listening.